Well, now we can define it a lot more granular. So we could define that anyone within my organization is now getting the Azure AI developer permission. We select the role and we allocate it to a user, a group, or we could also link it to managed identities. So I could go in the system managed identities, and now I can specify that my demo hub live that we created in the previous demo is now getting permissions to interact with my other AI service components. Even better, think back about bringing everything into our Azure AI Studio for as much as getting up and running as fast as possible, where we still have our hub parent scenario, where now if I refresh my portal, I go to the hub level. Down here, I can see a user section. So almost identical to managing permissions from an Azure resource perspective using RBAC, I could now create a new user, inviting the user into my environment. I would provide some name out of my user list or creating a new one. And again, we do have our different roles here. Now, owner, contributor, reader are the generic default users, where now you can see that preferably by default, we're going to allocate Azure AI developer. So two different ways to define RBAC from a resource group or resource level, or directly from within our hub. Deployed our Azure AI Studio, we created a hub, we created a project, and we defined RBAC permissions. Well, now finally we can shift to the actual deployment of a model. And why not maybe multiple models? So I go back into my hub, I switch to my project level, and down here, I'm going to interact with the model catalog. Now, the benefit about the model catalog is that it's really that central point where you can find all possible available large language models that you can deploy on top of your Azure AI Studio. So for each and every of the models, you can define some filters. You can define how you want to deploy them. You can filter based on fine-tuning tasks, like some of the models are maybe helping you with text classification. Some of them, like I would say the GPT ones or the Llama ones we talked about, are the ones you're going to use for chat completion. So out of this massive catalog, you can create your own filters. So from there, let's say I want to deploy GPT 3.5 Turbo. You can also use the search functionality. So let's do GPT-3.5, where it's still giving me all the different 3.5 options. I'm going to use 3.5 Turbo just as an easy example. And even without knowing anything about the model specifically, it's providing you a nice detailed description. And there's also a pointer to additional documentation about that specific model. From here, you can define fine-tuning that I'll talk about a little bit later on. Now, keep in mind that not all large language models actually allow you to do fine-tuning. It's also the reason, if you remember, in the first step of my deployment of the AI Studio and Hub, I picked Sweden Central because that's one of the regions actually offering models for fine-tuning. From here, you can actually decide on deploying this model, which means I'm going to bring in the large language model capability. I'm going to create an endpoint, and from there, I can start integrating it into my applications. It comes with a default name similar to the flavor of the large language model. And I still like to give this a little bit more of a descriptive name, where I'm following the same naming convention, where now this is my demo hub live, that's my hub and my project, GPT 3.5 Turbo deployment name. I can define the default settings here, the model version, the version of the API you could say that the model is using, which Azure services and project it belongs to, and it can also allow me to define the capacity. Now in my example here, 100,000 tokens per minute is probably way too much. So I'm going to lower this down a little bit. Now in your own environments, in short, the way an Azure subscription works with AI services is based on quota limits. So there is a certain set of quota per region, per project that you can allocate. And every now and then, if you just go next, finish, and accepting the defaults, you might run out of quota, where some of the testing out of the chat playground might not work anymore. So that's where I would recommend you, at least in a test environment. Obviously for production, the settings will be totally different, but in a test scenario, validation scenario, I would recommend you initially at first to move down that number of tokens. Like in this case, 5,000 allows me to have 30 interactions per minute. That's like firing off a new chat prompt every 2 seconds, which is probably not what I need even in my demo environment. And I'm going to deploy it. So the deployment is done. Important here is the target URI. That's what we need as AI solution developers to integrate it within my application. And we also have the key where obviously it's a little bit encrypted here on screen to make sure that not just everyone looking at the Azure portal gets eyes on the keys. Most important after running our deployment of the model is testing it out. The best way to test it is using our playground. I talked about the playground a little bit in one of the first demos, just the interface, you could say, to validate your environment. So what I can do here is firing off a prompt, asking a question, as we call it, and just asking, what can you help me with? So this is a pretty generic prompt where I'm just relying on a test, because in the end, the goal of a large language model is based on a prompt, based on a question. The input, as we will call it later on, is asking a prompt question and waiting for an accurate response. So in this case, we didn't really specify anything, but I have, I would say, the confirmation that my large language model is working. A little bit of a different test is validating something about an actual piece of information, like what is the weather like in Seattle around August. For now, it's relying on public internet information, how the large language model got trained, and it's going to tell me here a nice description. In August, the weather in Seattle is generally warm, pleasant, with highlighting some of the temperature details in Fahrenheit and Celsius, and a little bit more on that. I could also ask something around who is the Prime Minister of the UK, where I'm now validating what date, you could say, what is the timeline when that model get trained. So in this case, it's not really specifying it yet. So I could ask, like, up to what date did you get trained as a model? Where it's not even exposing any specific training date, but I'll try to bring in yet another example in the next second, and then hopefully it's going to tell me how that actually works. So to give you an idea, we're going to add an additional model. We deployed GPT 3.5. It's I wouldn't say outdated, but if you follow a little bit in the large language model space, you probably heard about GPT-4 and even later GPT-4o. So again, same as before, I select GPT-4 as my next large language model. And in a real life example, building your custom copilots, right? It might end up in deploying multiple models that you're going to use within the same application solution. So I'm going to deploy it same steps as before. I'm going to follow my own naming convention standards a little bit. I'm back in my chat playground, where now from here, I need to give it a little bit of time. We're now here in my chat playground. I still have my previous 3.5 large language model, where now I can switch between 3.5 and 4. So let's do the same test as before, switching to large language model type GPT-4 and asking the same question, what is the weather like in Seattle in August? And as you can see, no surprise, the answer is about the same as the previous one using the other model 3.5, Why is that? Because it's factual information. The weather is not really changing based on the date when that large language model got trained. But I'm again going to try, who is the Prime Minister in the UK? Another interesting one here is that there is a typo in my prompt, but it's not really blocking the usage. And for some interesting reason, it's still not really exposing the date. So let's try something different. Who is, let's say, is Queen Elizabeth II still the Queen in the UK? Why am I doing this? Because every now and then, based a little bit on the prompts, it's going to tell you like, well, based on my date of the training model, it's telling me like, well, as far as I know, from somewhere June 2021, for example, it was still the case. So that's what I'm trying to unlock here. But I might bring in a few examples to try something different later on. From here, I can show you how to deploy other models. So I did the same demo, deploy GPT 3.5, GPT-4, where now I can filter based on different vendors. So I talked about Meta with the Llama, large language models, and as you can see, that library is also quite extensive. So I'm going to use just the first one here in my option list, and now it's providing, again, additional documentation. This is the use case for this Llama large language model. There's some information about pricing, there's information about the tokens, and I would again recommend you, before you start just going out and deploying a model, really looking into the details, already nicely integrated here, but obviously maybe even looking at the original vendor source, but the deployment is exactly the same. For now, it's going to ask me a few additional questions, but the baseline is roughly the same. Just want to show you this. I'm not actually going to deploy this because I'm not really needing it in any of my future demos, but just giving you that experience that depending on the large language model you select in that catalog, the way you're going to interact with it, the way you're going to deploy it might be slightly different. But the baseline is, now you know about the model catalog and you know about the deployments. Last little piece here is starting from a different location, but technically doing the same thing. So we started with the model catalog, like give me access to that full library of AzureAI integrated, supported large language models. Where now, after running a deployment, I can also actually validate them from here. So initially we deployed Demo Hub Live GPT 3.5. Later on we deployed GPT-4, where now from here I can yet deploy another model. Where obviously this list is exactly the same as going through the catalog. Two different locations to basically end up with the same outcome, how to deploy a large language model. Let's move on with the rest of the presentation, looking at different scenarios. So there's a couple of keywords here. Accuracy means how well does that large language model interpret the prompt. I'm giving a prompt like, again, what's the weather like in Seattle? And obviously, as a user, we're assuming that it's going to provide a good answer. But imagine that it's not always providing that exact correct answer. And I'll show you some examples later on how you can actually play and manipulate, think back about the groundness that I already talked about before. But accuracy is really how smart, you could say, is that large language model to interpret my question and providing a decent answer. Where next to that, the coherence and fluency is a little bit more towards the natural language processing aspect of it. Like, it's going to recognize the prompt, it's detecting the question, it's going to provide you an answer. But apart from like how accurate is that answer, the coherence and fluency is also checking like how fluent is this, like how close does it represent a human-alike answer. So it's not only about technically being correct, like the answer is really giving you an actual fact, like this is what the weather's like in Seattle in the month of August, why not? But then also, how is the natural language processing integration giving you that answer? Does that sentence make sense? Is it like correct from a grammar perspective? So that's mainly what coherence and fluency is doing. The groundedness is where later on we're going to bring in our own data sets. We're now out of the benchmark. We're going to know and we're going to validate like what is the ranking, the number, if you want, that gets allocated to that groundedness, where it really means like I have my custom data set, like in my travel agency example that I use later on. I'm going to bring in some flyer information, a brochure, if you want, from different places in the world that my customers maybe want to visit. So when I'm asking a prompt like, what can you tell me about London? What can you tell me, like, what can I visit in London, for example? I want to make sure that all the data is not only correct accuracy, is not only presented in or described in a natural language, human-alike way, but I also want to make sure that the answer itself, the data to really provide me that answer, is as close, as accurate as possible to the data from my data set. And that's what the groundness is doing. And then overall relevance is really like based on the purpose of your solution component, like what generative AI functionality do I want to integrate, where it's going to identify based on chat conversation, GPT would be okay, the Meta Llama would be okay. But again, the DALL-E example is not going to help you for chat completion because that language model cannot help you with that. So that's where that relevance comes in.